Hey everybody, I'm Rashid. Yeah, we need to talk about that third part of the course and review some examples and explain them. So I will use the review you have and post this video probably to YouTube so we get closed captioning thing and make it accessible to other students from different sections. So the idea before we start, so by now, as you worked on the math and you start to recognize if there is a mistake, what type of mistake it is. Because it's important to categorize the mistakes so in order to fix them. Sometimes we say, well, I always do this, this same mistake. So we need a strategy to fix it. And in order to have a strategy, probably one way is to bring it together as a group. So for example, we'll say, yeah, I missed a couple of questions because I wasn't sure about them. That means we didn't study them or we didn't understand them well when we studied them. So that's a few things you need to catch prior and ask me about it, anything that's not clear. So the concept or the knowledge is one part to know. So for example, the first question here, we're dealing with the vertex. So if you know the vertex formula for the quadratic function, you can easily solve a minimum or a maximum application. The second part is the computation. Of course, for example, we're not supposed to round or chop in the middle until we find the final answer. Then we see, if there is no request to round to anything, it means the answer has to be that way. And if you have an answer that has multiple digits and after the decimal and you want to round it and you don't know what to round it to, we can't decide, okay, for this one, I'm just going to round it to 2 places. So if the question does not ask to round the final answer, that tells you that, yes, probably something was incorrect. The other part is human error, or some call it online reckless error or something like that, which means we didn't keep attention, for example, when we copied the problem in the first place. That's an example of it. If like the first problem we have, if it's 1.2x squared and you copy 12x squared, so if 1 and 2 exist, we know how to solve it, we know the vertex formula and all that, we did the correct computation, we're still going to miss it because we're solving a different problem, not the given problem. So these are the 3 things to watch for. And as you work on your review and practice and all that, you always want to find what is it that keeps occurring and how do I fix it. And of course, you ask me questions and I'm here to help you figure out, because not everything you'll figure out on your own. So keep that in mind. So let's share this screen here, and we can go ahead and work on some examples for this video and then leave others to a next video. This first question here talks about a company manufactures copy machines. The cost C, which is the function C of X, is the cost in dollars to make each copy machine. So if X machines are made, then the unit cost is given with the function. So you read it a few times, and we talked about the strategy of looking at the question first to find out what it is asking, right? It's asking about what is the minimum cost. And then we look at the function and we know it's a quadratic. Then does this function has a minimum? So that's one question. Yes, it does have a minimum because A is positive. So I'll write these things down just to give you the thinking process that we're not gonna solve it right away. We should think about it and find out how to solve it and what is the question, what it is that's given. Really what's given is just the function c of x. Everything else is just a story. And you see the not around your answer. So the question has to be, or the answer has to be, let's say 5,000, 20,000. It's not 5,000.25678 non-terminating number, and we round it to the dollar or something. What else? The third step is, of course, what we need to solve this thing. Since it's a minimum and a maximum, we're going to need the vertex formula for this type of problem. Then we solve, right? So the fourth step is solving. With practice, we get used to this and we just go ahead and solve it. But there is a process that's happening. So the fourth step is solving, and the fifth step is checking whether we actually answered this or not. Like I mentioned, for the errors, if I copy this as 12 and I solve it, well, yeah, probably have some correct answer, but for some other problem, not this one. That's one idea when we work on this, is to make sure we are recognizing that each time we work on something, we're doing a process. And there is a process of solving. And if you keep that in mind when you deal with things that are not even math, you're still gonna reach to the solution or be close to the solution and reevaluate again, because you're following a process and checking at the end, right? Some of this stuff I'm not gonna talk about again in some other parts, but since this is the first one, it's worth to talk about it, and just have reflection at the end. What is it that we're doing and why we're doing it, right? So if we look back at this and compare it to what we know, it looks like the quadratic function that we've worked with different times. And if A equals, in this case, 1.2, which is positive, so if A is positive, we say that the graph opens up, right? A is positive, it opens up, and it gives us a minimum, or the vertex represents the y value represents the minimum. And we talked that this vertex is negative b over 2a for the x part. So yes, we do have a minimum, and the minimum can be found in this case by having two steps. Step one, we calculate the value of negative b over 2a because the vertex occurs when x equal negative b over 2a, right? And the second step, each time we worked with this and we say x, when you find the value of x, how do you find the y value? And of course, always the answer is to substitute back into the function. So if you substitute back the value of negative b over 2a, then you're having that second step here, and you're solving it. All right, so that's the idea, and some will say, yeah, so because as you work with this and you put things together for the end, you'll say, well, why would this one be two steps and the ones we did previously are one step, right? That's a good question, because the ones we worked on in the past, like for example, projectile, it was also a quadratic function, and it's in terms of t time, And for example, one of them asks about when does the projectile reach certain height. And as you see, let's say 500 yards or something. And as you see, when it goes up, it reaches 500 yards. And when it comes down, it reaches 500 yards. So in that case, we solved it by using either factoring or quadratic formula. And we found, for example, for the answer, 2 positive answers. And we accepted both answers. Then we did some other examples where one is negative and one is positive, and we rejected the negative answer. So even though the math was correct, we had to make the decision to reject the negative answer because the time cannot be negative. Let's try this one now to find this numerical value. So x is negative, and b in this case negative 744 over 2 times 1.2, and 744 divided by 2.4, so it's 310, and that gives us that first step. Then we do 310, and as we mentioned now, x, which is that placeholder, is 310. Uh, 123,296. All right, so 310 squared. So I'm doing it probably the same way you'd be doing it, working on it, so you can see the steps, and of course, as you get used to it, you skip some steps or something. But the important part is we know what's up, right? And the final answer is correct. And if it's not correct, we know why it's not correct. All right, so if you have if you're using the basic calculator, kind of scientific calculator online, same one, then probably you'll be storing numbers or you'll be writing them down this way. And that gives me a 7,976. All right. So recap. You have a graph. You have a function that's acting, that way. Then you have 310, and the minimum 700,976. All right, and we didn't need to round it. It is what it is, and that's it. We can check it if we want to as the other step. So find the equation for the quadratic function that is whose graph is shown below. So for this type of, we know it's quadratic because it's a problem. And we know that f of x, now you've seen by now 2 forms, ax squared plus bx plus c, or a with the vertex minus h, and hk being the vertex. So h is opposite in kind of in inside, and same for k, same sign outside that we're used to, right? Since we know the vertex hk, then we're going to use this form, And we don't know the leading coefficient, but we'll figure out. So x minus 5 squared plus 7. And, you know, we talked about f of x being the y value. And anytime we put xy, you know, before, it's a point on the graph. And in previous example, you take the function, you substitute numbers to find points, then you use those points to graph the function. Now we're doing the opposite. We have the point on the function and we're using it to find the equation. So it's, you know, we're using this point now to fix the equation. So here x and y, right? And we use them. If this is not given, we need to find the point on the graph, right? But of course, a point that can be easily figured out. So a 4, and a is just a, and x is a 6, and a 7, and a times 1 squared, which is 1, and we subtract the 7 both sides and give us a, and a now is -3. So if for some reason your answer is 3, right? Positive a leading coefficient means the graph opens up, but this graph opens down, so our answer is correct. It matches. So now that's it. So we have leading coefficient, we have the HK, and that's it. So you can try take points from this, plug them in, and you substitute them, and you'll find the same graph. So you can pause the video and try it and see. But I think I'm going to do maybe 9 examples or 10 in this video, then do another one for some other set and do another one. So as we go through these examples, the purpose is not just to solve, but also compare. You know, we got number 2. It's almost like, you know, the answer that we got in number 2, now we're asked to reverse it in number 3. And that's the idea, right? To know how things work. So as you connect these examples, as you connect the concepts, things, the understanding gets better. So if we just did this, then we know this HK are a 4 and a 3. Of course, why it's not -4? Because x minus 4 equals 0. Or the graph shifted right by 4 steps. So let's put that here for 3. That's the vertex. A is -2, so the graph is supposed to open down. So if I'm coming up with points here, then that's not correct. Once you have the vertex, you need few points on the left and right side of the vertex to make that curve fit. All right. So you would ask what values to take. It doesn't matter, but stay close to the vertex so the points fit in the frame, right? Because you want them to fit in this frame. So if x is, let's say 5, then y is going to be 5 minus 4 squared plus 3, -2 times 1 squared just 1 plus 3, -2 plus 3, which is a 1. So if x is 5, then the value of y is 1. All right. We know using the symmetry, x equal 4 is the axis of symmetry. If this point is here, then it's going to be here for this value of x equal 3. So we don't need to find that point because it's kind of given using symmetry. And the axis of symmetry is x equal 4. So let's try another one. If x equals 6, then y is going to be negative 2 times 6 minus 4 squared plus 3. Negative 2 times 2 squared plus 3. Negative 2 times 4 plus 3. And negative 8 plus 3. And negative 5. So for 6, it's going to be negative 5, which means for 2, it's also going to be that, right? Okay. And you graph, because I want to make sure they go through the points. It's not graphing, it's not the best thing here, but we'll try to make it a little bit better so it does look all right. That's it. So this is the function, and this is its graph. And you compare 2 and 3, and you understand now how it works for these quadratic functions. So we're going to move to a different topic in this question 4. Suppose this polynomial f is given in this kind of factored form. List the zeros and their multiplicity. The zeros are when we set these factors to 0, we'll be able to find the zeros. So sometimes if there is x there, the question comes up, should we use it or not? Well, set the factors to 0 and you find out, right? So if it's 2x, so just show you here, 2 equals 0, that's not possible, right? So, but if it is, if 2x, or or just written as this way, then 2 is not possible. But if you do x equals 0, then it is a 0. In that case, you have to include it as one of the zeros, and the multiplicity is 1. So for 2 here, nothing, no 0 there. For x minus 7, x minus 7 equals 0, will give us a 7, right? X plus 5 equals 0. This one here. X equal negative 5. The next one here, x minus 4 equals 0. X equal 4. And so let's, we're kind of finished, but we need to answer the multiplicity. So if we take 7, the multiplicity is 2, and we talked about it. What does that mean? If you have squared, means this. So it's x equals 7, x equals 7 twice, double. So the multiplicity is 2. So if we need for the multiplicity 2, then there is a 7. The second one is negative 5. It also has a multiplicity of 2. Multiplicity of 3, there is a 4. We don't have any 0, that's multiplicity of 1, right? That's it. So this allows us to understand the zeros and their multiplicities, because later on we're going to use them in the graphs. So if you look at this question, we also 4 and 5. From 4 we found the zeros. Now if you're given a zeros and we know the degree is 4, can we reverse it? What is the factored form? So here don't forget to write f of x. Find the polynomial f of x, so it's f of x that has the following zeros. Leave your answer in factored form. So it's just x minus 6, x minus 5. These other one will be opposite there, and x minus 0. Similar, the confusion that happens there could happen here. What happens with the 0? The same thing. X minus 0 equals 0. So x times x minus 6, x minus 5, x plus 4. That's it. There is no discussion about leading coefficient and stuff there, and points. And so for this one, that's what we're given as far as for the information that we have. That's the solution. All right, so let's scroll down. All right, so question 6, is it similar or different? So for find all x-intercepts and y-intercepts of the graph. So we're taking pieces so we can go to a bigger problem that puts all the pieces together. So here we kind of generalize this to, if we look for x-intercepts, then we do, they occur at y equals 0, which is in this case f of x equals 0. And for y-intercepts, it occurs at x equals 0, right? So this kind, like, if there is one, then it follows this. So for x-intercept, y equals 0, which means x cubed minus x squared minus 9x plus 9, and we're used to put this 0 on the right side. So this is 0, right? So it doesn't matter whether it's on the left or right. If you're used to having it on the right, then you just move it to the right side, right? Okay, so let's clean this. So if we keep this for notes, then somebody reading the notes, we know, what happened. They'll see 0, they'll be like, why this function started with 0? Yeah, so we'll just clean it up. At this point, we try to solve, but we haven't solved or studied different methods. Probably we did some of them, but not all other methods. So this is a third degree, but we did work something like this where we have 4 terms, right? And we said if you have 4 terms, then you can do factor by grouping. Which means you're gonna take these first 2 terms and group them, right? And 9x plus 9, kind of grouping them. This may not look correct, but just to show, so maybe we'll put a box, not just to confuse. Then we'll ask what is the greatest common factor that can be taken out of these first two. And we have x and x, but this is two x's, so the x squared and x minus 1. Then for a 9 and a 9, but if this is a negative, then we take a negative. We don't take just 9, we'll take negative 9. And the common mistake is just to say you take out 9 from here and 9 from here, you factor them out, then you leave it this way. So a quick check back, negative 9 times x is negative x. Negative 9 times 1 is negative 1, but this is a positive one. Also, this here does not match with this, which won't allow to continue. All right, so we need to fix it. That way, right? So negative 9 times negative 1, that's a positive 9. And this will allow us, why we did factor by grouping, then we find a group that is common. This x minus 1 is a common group. So think about, we've done it, so now it's just like a review, but reinforcing that review. So if we take out these x minus 1, we factor it out, then what's left here is x squared. And similarly from here. So we've done this so many times. The question always is, did I factor completely? You factor and now it's done. For this type of question, if we solve, we can find out that we didn't factor completely. But to get used to the idea that we always try to factor completely, then this is a difference of squares. So it is a difference of squares, right? So a squared minus b squared is a plus b, a minus b. And whenever this shows up, it is factored, right? So this x-intercept is the one that has some work to it. Y-intercept is not. It's kind of easy, straightforward. And once you have it factored, the degree is the third degree there. We have 3 factors. That's another hint, right? If some reason, some reason this did not show up this way, so we're expecting 3 zeros from that and for this type of problem. Then we set them to zeros, and we've done this before and now. So the first one will give us 1. The second one, x plus 3, will give us negative 3. And the third one will give us 3. So we set them to zeros. X minus 1 equals 0. X plus 3 equals 0. X minus 3 equals 0. And will give us the x-intercepts. So factoring plays a good role here. It's a pretty important skill to have, right? It's an important skill to have. Maybe I should put 5 stars on it or something to show that it's important. So I want to go too fast on this, so you can review and see. If you're following the video, I'm doing the almost same way you'll be working on it. You'll probably be skipping steps that I'm doing. But it doesn't matter as long as we understand what we need to do in order to find a way to solve. Here it's factoring by grouping, and that's the way to solve. Then when we get to the y-intercept, so maybe we'll try a different color just because this screen is getting busier. So for y-intercept, x equals 0, 0, 0, 0, 9, right? So this one is not a problem, right? Easier. Bulking this again. So if somebody just looking at the notes, then it's not confusing. So now you're looking at these properties and you have different ways of figuring them out. So a final example for this video is putting few things together to figure out the picture here. But for the level of the course that we're working with, college algebra, so if the curve is turning, we're not going to be figuring out the turning points on all that. We will just see how the pattern is and get the idea of how the function looks and whether it has intercepts and where does it touch the x-axis, where does it cross it, what is the end behaviors and stuff like that. But this is a polynomial like the ones we talked about. So we expect a smooth curve. So you're not going to be doing so you're not going to be graphing something like this, right? It's a smooth curve. You know, I did a corner there. I'm trying to say that we're not going to have any corners, right? It's a polynomial. So if we did the parabola, right? And it goes something like that. So something like this. So that's what we mean with this smooth curve. There is no corner and we're not jumping as well. So it's not like you come to some point and you jump the function and you keep going. We have f of x, and we're going to need to collect some information in order to have an idea about its graph. So let's put 1 here. This is a 2, and this is a 2. So 1 plus 2 plus 2 is 5, which is an odd degree. If it's an odd degree, then for polynomials, you expect them to rise on the right side and fall on the left. They all rise on the right, but with this leading coefficient here, with this leading coefficient here, it's negative, so this is going to switch. So let's just call it A. If this A is positive, then we're supposed to have this with that degree. But here we have A to be negative, so it's going to switch. It's going to rise on the left and fall on the right. So for this, choose the end behavior of the graph. It's going to be rise on the left and fall on the right. Right. So to understand what's going to happen is that will allow us to understand something like this, and we'll figure out the middle as we go. All right, so again, let's just clean some of this stuff here. All right. So did you, you probably went ahead and figure out these other things. So What did you think about the next one? So list H0. So we just talked about the zeros, right? The graph, if there is more than one, separate them. So the zeros where the graph crosses the x-axis. For the graph to cross the x-axis, the multiplicity has to be an odd multiplicity. So for example, this one, the multiplicity is 1, then at x equal 1, it will cross. These are 2, so for the touch, it will happen at the multiplicity if it's even. So for example, at x equal 2, the multiplicity is 2, so it's even, and there will be a touch there. And negative 1, there will be as well a touch there. So we can say it touches at negative 1 and 2, and 0 where the graph crosses, it's at 1. So we don't know yet how it touches, but we know it touches. And whether it crosses, you know, if it crosses, then we don't know yet if it crosses this way or it's going to cross this way. And a touch as well, is it going to touch open up, or if it's going to touch and open down. The y-intercept, we say that's the easy one to figure out. It's just this is 0, when x is 0, this is 0, this is 0, right? So we have 1 times negative 2 squared is 4. And we have negative 1, and we have negative 1 as well outside. So negative 1 times negative 1 is positive 1. Positive 1 times 4 is 4. 4 times positive 1 is 1. So, so we can write it here just to show. Okay. All right, so now we need to graph. You see now this difficult thing is not going to be actually difficult. So let's look at the zeros and take the far, either start from the far left or far right. Probably that's an easy way, because we want to be near these end behaviors, so we make the graph smooth, right? So negative 1 is here, that's 1, 0. 1 is here, that's another 0, and 2 is here, it's another 0. So it touches at negative 1. Since the graph is coming from here, then it's going to touch this way, because it doesn't make sense if we do this, then it has to, you know, the graph has to cross, then it touch. And we don't have a cross at some point here. So that's why we need to connect things to make it smooth and stay with the information that we have. So negative 1, and there is a touch. And if we go to the far 0 here is a 2. There is also a touch, and it's supposed to fall, right? Then now this will clear up 1. For 1, it crosses, so it looks like it should cross it this way, because if I put here, then it doesn't. So these are the ones you're going to select, right? And that's it. So if we want to graph after this, it's going to turn. And the y-intercept is the one I missed, is 4. So let's put that in. This way it looks much better. Y-intercept is 4. I'll put the points that we had. These are the dots. So this graph is going to bounce and come to 4, go up this way, and turn here, and come down this way. I didn't graph it nicely, so we'll try to make it nice now that we know how it looks, right? So you just to make sure everybody kind of sees the graph, how it looks now that we have the idea of working on this. So -1, touch, 2, touch, and 1, cross. 4 is just y-intercept. So no, not that good. And the touch there. All right, so the degree, as we mentioned, is, of course, you're going to tell the system to graph any graphs. So 5, and you can see the turning point. We have 1, 2, 3. This is it, and 4. So you'll expect the turning points to be 4 because the degree is 5. So it's less by 1, which means 5 minus 1, and we got 4. So this is one turning point, that's a second one, that's a third one, that's a fourth one. It's supposed to touch here, it's touching, it's supposed to cross here, it's supposed to touch here. There is no other crossing other than that. All right, yeah, so I think I finished for this video. The idea is to get an understanding of these graphs. So to complete the picture, if this was let's just a 2 and a 2, and this thing doesn't exist, then it's 4. In that case, so let's write them here. So if this is, for example, 2 and a 2, so the degree is 4, then it's supposed to be this way with A positive. But if A is negative, then it's going to fall both left and right. All right. Everything else is stayed the same. The way you find the zeros, the touch, the cross, all that stuff stay the same. And when the intercepts stay the same, x is all the x values are, or the x value takes 0, and you substitute and you find the y value, then whether it touches this way or this way, you'll use the end behavior to make sure the graph is nice and neat. All right, thank you, and please check the other videos so you can complete the review. And if you have questions, just let me know.